Okay, we're back, and now we're into the section where we have to decide on what type of graph to do. So they're not telling us use the cubic or use the logistic or use this. It's saying, all right, plot this data over here on the right, and this is going to be the case for the next two or three that I show, and plot it and look at the scatter plot, and then list the types of models that exhibit this behavior. Then after that, describe the possible end behavior as input increases and list the types of models that would fit each possibility. Then we want to write the model that best fits that data, and then after that, write the model that best exhibits the end behavior of the data. Okay, so looking at this one, what we have to do is we have to plot this in our calculator. So let's go ahead and go over there. So again, I've gone in and typed all of that in, and so now we can look at the graph. So it looks like it's increasing and it just continues to increase. Okay, so what kind of graphs would do that? Well, increasing with that would be, logarithmic. It could just continue on and on and on forever going up. Or it could be a quadratic. It could continue going up until he hits some max and then start coming down. Okay, so let's go over here and kind of write that down and then think about what the problem says. So I would say for A, we could have the logarithmic or quadratic. Okay, now describe the possible end behavior as input increases. Well, it says as the number of SUVs in millions are sold, we're going to make this much profit. Well, to me, that means if we sell 80 million SUVs, our profit should be going up even more, and 90 would go more. And so I think this is going to go up and up and up and be unbounded. And so basically, the more we sell, it's just going to continue to go up. Okay. What does that indicate? Well, not the quadratic. That indicates we're going to have probably the log. So in behavior seems to increase without bound. Now again, that means we have to keep selling more and more SUVs, which we have to assume, and then because of that, our profit in trillions of dollars is going to keep going up and up and up. Okay. Now, so write the model that best fits the data. Okay, well, I think because end behavior seems to increase without bound, it's going to be some kind of log model. So let's do a log. So we go stat, and calc, and our log is number 9, then arrow down, and I'm going to put, I'm going to do it all again, number 9, and arrow down, then I'm going to do vars, arrow over, 1, 1, and so this is what I get, negative 6.11, well, 12 plus 3.059 ln of x. Okay, so that's going to be my thing. Now 0.998, that's pretty high for an R value. So I think we're probably pretty good there. And as you look at the data, that really, really fits well. Now let's go ahead and do calc again. And we said the quadratic was the other possibility. So that's a number 5. So let's see what the quadratic looks like. And we'll put that in vars 2. Okay, now it's only 9899, so it's not as good a fit. And if you look, it's not hitting as many or getting to as many close points. So I'm thinking the quadratic is not the way to go. And so what we're going to do is we're just going to delete that quadratic. Oops, we'll have to clear the quadratic. And we're going to go with the log function. So let's go back over here. And the one that fits the log function was the log, or which fits the graph is the log function. And so P of, I guess, S for number of SUVs sold is going to be equal to, and it's going to be, what do we have? We had a negative 6.112 plus 3.059 ln of S. Probably should have chosen a different letter, but that's okay. And that's going to be $1 trillion, it says. So $1 trillion for the profit of the sale of S. Um, million SUVs. All right, so getting all the units and everything right. So is again, I should have chosen another letter beside S, but that's what it is. And S is less than or equal to, in this case, 70, but greater than or equal to 10. Okay, so that's our model. Now it says write the model that best exhibits the end behavior of the data. Well, that's the same model, so I would say C part C, because that was the model that fit. We tried both quadratic and the log was the one that fit the best and matched the end behavior, because we plotted them both. And if the other one, if the quadratic had given us the better fit of the data, we would have chosen it. But then we would have said, okay, in the end behavior, then it would have had to been the log. Okay, but the log actually fit the behavior of more points fit or closest to, as well as fitting the end behavior. Okay, so that's how I would do this number 19. Now I'll pause and get another one.